Today, we're talking about one of the most important concepts in arboriculture and urban forestry: right tree, right place. Because most tree issues we see in Southern California don't come from bad trees. They come from trees that were not well matched to their planting environment. Urban tree selection is the process of matching a tree's biological characteristics to the conditions of the site. This includes soil volume, water availability, heat exposure, infrastructure constraints, and long-term canopy development space. Tree performance is highly dependent on how well site conditions align with species-specific growth requirements. A tree does not fail because it is inherently bad. It declines when the environment does not support its long-term physiological needs. Southern California presents a challenging environment for urban trees due to multiple interacting factors. These include long dry seasons, high summer temperatures, reflected heat from built surfaces, compacted soils, and limited rooting volume in many urban landscapes. Because of this, species selection plays a critical role in long-term urban tree performance. Fun fact: one thing that surprises a lot of people is that most tree roots are actually concentrated in the upper layers of soil, not because they're shallow by design, but because that's where oxygen, moisture, and nutrients are most available. In urban environments, that same zone is often the most compacted and restricted, which is why soil conditions matter so much for long-term tree performance. Tree growth is governed by species-specific biological traits such as canopy form, root architecture, water demand, and structural development patterns. Management practices like pruning and irrigation can influence how a tree develops, but they do not fundamentally change its genetic growth characteristics. Arboriculture guides development. It does not override biology. Urban trees are often selected based on functional roles. Shade trees, such as ash or tipu, provide rapid canopy development, but may require long-term structural management depending on site conditions. Flowering ornamentals, such as jacaranda or crepe myrtle, are selected for seasonal aesthetic value. Evergreen screening trees, such as podocarpus or Brisbane box, provide year-round coverage. Drought-tolerant Mediterranean species, such as olive trees, are commonly used in low-water environments. Urban forests in Southern California include both native and non-native species. Native trees, such as oaks and sycamores, are part of local ecological systems and support wildlife relationships. Non-native species are widely used in urban environments due to its adaptability, performance characteristics, and historical planting trends. The most important factor is site suitability, not origin alone. Common challenges in urban tree establishment include selecting species that exceed available mature space, limited rooting volume, mismatched water requirements, and lack of long-term planning for growth. When these factors are not considered at planting, the likelihood of future maintenance conflicts and structural issues increases significantly. All right, now I want to take some time and answer some call-in questions.
Hello, my question is, what is the best low-maintenance tree for Southern California?
There is no single low-maintenance tree, but species that tend to require fewer long-term interventions often share traits like drought tolerance, moderate mature size, and stable structure. Examples include olive trees, podocarpus, and some native oaks depending on site conditions. Low maintenance doesn't mean no maintenance, it means fewer conflicts between the tree and its environment over time.
Howdy. Why do cities keep planting the same trees everywhere?
Cities often repeat species because of proven performance, nursery availability, maintenance familiarity, and historical success in similar planting conditions. That's why you'll often see patterns in city plantings, because once a species consistently performs well under certain conditions, it becomes a dependable choice for similar sites.
Hi. Why do some trees lift sidewalks?
Sidewalk lifting is typically associated with root growth in confined soil volumes, compacted soils, and limited rooting space. It is not intentional movement by the tree, it is a response to available soil structure, moisture gradients, and physical constraints. If site conditions change, root development patterns can also change.
Hi there, this is Jenkins. My question is, are native trees always better?
Native trees are important for ecological relationships and wildlife support, but they are not inherently better in every urban situation. Non-native species may perform well due to adaptability or tolerance to urban stress. The key principle is always right tree, right place. All right, guys, it's quiz time. Let's see how many of these you can answer right. What matters most in urban tree success? Urban tree success is most limited by below-ground growing conditions, especially usable soil volume, soil quality, oxygen availability, and water access. Why do fast-growing trees often require more management later? Fast-growing trees often require more management because rapid growth can outpace structural development, leading to a higher likelihood of weak branch attachments, lower wood density in some species, structural defects over time, and increased pruning and risk management needs. What is the primary goal of an arborist? The goal of an arborist is to manage trees for long-term health, structural integrity, risk reduction, and ecosystem function within the constraints of the site. If there's one takeaway from today, it's this. Most tree problems are designed at planting. When we match the right tree to the right place, we prevent decades of issues before they begin.